Good evening, friends. So, we are using DC series motor in the old locos in Indian Railways. Now it has been changed with three-phase induction motor, the traction motors. Now, the old system. In old system, we are taking 25 kV single phase AC in the main transformer, and from there we have taken two silicon block rectifier for feeding three traction motors and another two three sorry another one for another three traction motors. Now the principle to change the voltage against the traction motor, we are using auto transformer. If we change its step, if we reduce, the voltage will be reduced. If we increase, the voltage will be increased, and thus we are controlling the speed of the locomotives. But it is a complicated system. Driver is having a MP, just like in our car, a wheel. With this thing, he is changing the voltage across the traction motors. It has spring action. You can increase or decrease, but it will immediately return to its neutral position. Again, you take another progress, and again voltage will be reduced, regress, voltage will reduce, progress and regress. But after changing this notch to notch progress and regress, any change after it will come to its neutral position. But suddenly, if you need regression due to some emergency or due to some reason, or your signal is red and your train is running with high speed, then you regress it will automatically will be reduced. So voltage we can change with this system auto transformer principle. That means if your turn is in comparison to primary is more, your voltage will be more, and if your turn is reduced, not the word is not right. Actually, auto transformer, if you take full turn ratio turns of the primary, then it will give you the same voltage, but we are keeping it tapping maximum voltage. From maximum voltage, that means it cannot cross the main transformer turns. Main transformer voltage will be always more, and some portion of its winding we are using as traction motors, so its voltage will be always less than the main transformer. Main transformer voltage is 25 kV, and for our locomotive we are using around 750 volt AC. So the voltage is somewhat less. In our time, the current can be reached up to 1000 ampere. So when your voltage is reduced, your current will be more. So according to the tapping, if you reduce the tap, then the voltage will be less. But if you raise it, the voltage will be more. Voltage will be more, and if your load is fixed, if voltage is more, current will be more, and if you reduce the turn or tap, then the current will be less. That means it's primary to secondary, the power is same. So the relation voltage and current, if your voltage is more, current will be reduced. That is not true here. For a transformer, the primary and secondary power is same, kVA is same. But voltage, if you reduce the voltage in the secondary, your current will, you can take more current, and if you increase the voltage, the current will be reduced. This is the principle. That means transformer primary and secondary kVA or volt ampere is fixed, but this fixed volt ampere, if you raise the voltage, your current will be reduced because the volt ampere is fixed. Voltage will increase, current will reduce, and voltage will reduce, current will be more for fixed load or fixed power. So this is the principle of the transformer. Your primary and secondary kVA is fixed. Simply you can change the voltage or current. If your kVA is fixed in the secondary, if you raise the voltage, current will be less, and if you reduce the voltage, current will be more for fixed kVA. But in the turn, when you are changing the turn, your kVA output will also be affected accordingly. Suppose your turns, okay, not to go deep here, but simply the primary and secondary kVA is fixed. Primary and secondary kVA is fixed. Your turn, if it is fixed and you take tap, if you change the tap, if you reduce it, your voltage will be reduced, and if you raise the voltage, raise the tap, voltage will be more. So in locomotive, we are using SMGR, servomotor graduator. What's this thing? This is a beautiful thing. Here in the picture they have shown three positions. With the movement of the MP, this shaft is rotating and some contact is made and some contact is opened. But suddenly if you change from one contact to other, then there will be a break in the supply system. So this is not the system. Just like our OIC, when you are changing from one tensile length to a new tensile length, there is an overlap zone. Here also we are doing some overlap. You cannot break the contact fully, immediately. First you change and then there will be an overlap position and then it will make the contact. From one contact to another contact, you suddenly cannot jump. There will be a spark and current may be interrupted. Beautiful system. I have forgotten. I have worked in the 1986-87. Again, I'll try to recover my knowledge. CGR1, CGR2, so many beautiful things. In the coaching trains, passenger trains, possibly the tabs are 40, and in the goods there is 32 tabs in the auto transformer. And in this way we are raising or reducing the voltage across the motor accordingly the current array. If your loco is stalled, then initially you take little voltage, but your current will be more because train is stalled. But if it will rotate, your load will be reduced. When the wheel movement will start, your load will be reduced and your current will be reduced. Then again you raise the voltage. Again, this step by step you can increase the speed of the train. But initially loco is taking more current due to starting. Though voltage tap is little, voltage is applied little, but current is more. Now this is another type of. So how many types of contact we are using? We are using electromagnetic, electropneumatic, and this type of CAM contactor. Loco is using this type of contactors. Electromagnetic is used for loco pentodazing, and electropneumatic, because with the air pressure the pento is raising. Simply the electromagnet will open a hole and the air pressure will raise the pento. EFDG, MTTG, that circuit will be shown in the letter. And how this shaft is changing its position, that has been shown in the last position. Okay, thank you friends.